A proportion is when you have one ratio set equal to another ratio. So it's an equality of two ratios. So it looks something like this. We'll have one ratio, maybe like A over B, and we'll have that set equal to another ratio, C over D. And this entire equation is considered a proportion. The left-hand side is a ratio, the right-hand side is called a ratio, but the entire equation is called a proportion. Now what will typically happen in a proportion is you'll have some unknown somewhere on the left or right side of the equation, and oftentimes these will be attached to word problems or application problems. Let me give you a simple example. Let's say there was a young boy in a neighborhood, and he cut grass, and he could cut 3 yards in 2 hours. So he could cut 3 neighbors' yards in 2 hours. But then we wanted to know how many yards could he cut in 10 hours. And so what we do is we set up a proportion that asks that question. So the ratio of how many yards he could cut relative to how many hours it takes to cut them would be 3 to 2. 3 yards in 2 hours. And we'll set that equal to an unknown number of yards in 10 hours. And so as long as this ratio stays 3 to 2, we can create a proportion, and our goal will be to solve for x. Now how we do that we'll talk about in just a minute. This particular example is relatively small. We can probably just guess the solution, but in just a minute I'll give you a more systematic way of finding this. Obviously he would have to repeat 3 yards in 2 hours. He'd have to do this 5 times for 10 hours because he's taking up 2 hours at a time for each of the 3 yards. So we'll multiply 2 by 5 to get 10. We'd have to multiply 3 by 5 to get 15. So in other words, he can do 15 yards in 10 hours. And that's the equivalent statement as saying 3 yards in 2 hours. But that's not a great way to do it. That's just using our good old-fashioned intuition. The way we typically solve proportions in an algebraic manner is using something called cross multiplication. It's an extremely helpful algebra procedure. It looks something like this. If you have A over B set equal to C over D, if you have this proportion here, then we can actually rewrite this by taking A times D and setting it equal to B times C. So this is equivalent to A times D equals B times C. And this is obvious why this is preferable. This does not have any fractions, and it's usually easier to solve. Now please understand, cross multiplication is not magic or anything like that. It's got solid fundamental reasons why you can do this. If you just wanted to use straight up algebra to rewrite this, notice you could multiply both sides by b, and notice what would happen. On the left hand side, the b's would cancel, and we could also multiply both sides by d, because as long as we do it to both sides of the equation, that's legal algebra. And notice the d's would cancel on the right hand side but not the left hand side. And so what's remaining at the end of the day is A times D equals B times C. So there's good fundamental reasons why cross multiplication works. And so let's go back to this example here. If we wanted to solve this more systematically, let's erase this here. If we have this ratio 3 over 2 equals x over 10, then what we can do is cross multiply and get 3 times 10 equals 2 times x. So that's an equivalent equation, but the reason I like this one is that it doesn't have any fractions. So if 30 equals 2x, divide both sides by 2, and x equals 15. And that's the same answer that we got before, but we got this one in a much more systematic way. And this is how we'll do this when these proportion problems get really, really big with lots of terms and big fractions set equal to other large fractions. cross multiplication will be extremely helpful in solving these proportions. All right, now, before I let you go, I want to mention one caution. This is a mistake that a lot of students make that I want to guard you against. Students get really good at cross multiplication. They have A over B equals C over D, and no doubt this is absolutely equivalent to A times D equals B times C. That's 100% true. But students wind up confusing that with multiplying A times A over B times C over D. And what students will want to do is somehow take A times D and set it equal to B times C. And that's absolutely the wrong thing to do. If there's no equal sign between these two terms, if it's not a proportion, you can't do cross multiplication. And so usually that's just an oversight by students. They're just not paying attention. But now that I've called your attention to it, just make sure you don't make that mistake on a homework or a test.